Hey, today we're going to look at a very fascinating topic and we're going to try to understand and give an answer on um, the question if GitOps can replace your CI/CD practices. Bojan, can you brief us a little bit on what we're going to talk about in more details?
Absolutely. Hey everyone. So what we'll be going through is can GitOps enhance or even replace your CI/CD best practices, but in the shape of kind of focusing on CDK, EKS blueprints, and a touch of ArgoCD.
Cool, this sounds very interesting and I'm excited to have you as this is also something that I've been doing in my day job recently. So, Bojan, before we go into details, who are you? How did we meet? What the hell brings us together given we're like 10 hours apart?
Well, funnily enough, I think what kind of brought us together was that it's late afternoon here in Sydney, and I'm assuming it's morning there for you in Germany. Yeah, spot on.
That's
But
true.
we're both community builders. We both are part of the wonderful program that AWS kind of put together for community builders and heroes. And, you yourself are a hero. And we both have a passion and love for both dev tools, a bit of serverless and containers. So I think, although we're on opposite sides of the world, we have very similar interests.
Yeah, that sounds like it. And I believe that we're going to have a very cool topic and session today as well because you have been doing this and I'm learning this. So before we go into details, how do you write GitOps? With a small g or with a big G? Capital G.
See, I think this is the punctuation person in me. I do write it with a big G, but only where it's applicable. Yet in the Slack channels and the various Discord groups, it's just whatever everyone accepts. It's kind of like the old conversation of do you do tabs or spaces?
That's true. Yeah, so why is GitOps appealing to you as a software engineer?
Well, my background came from a bit of software engineering and operations, and with obviously cloud kind of being the focus now, cloud changed the way we'd handle infrastructure, and to me, GitOps made things just a lot simpler. Now, with GitOps, you don't eliminate any of the wonderful things that CI/CD kind of brought in. Instead, it's I wouldn't say a parallel enhancement, but it's a continuous enhancement of what we previously had with the CI/CD process. Application configuration and what do you call infrastructure living in the one place, being articulated and executed in a fashion that we had to, in a way, roll ourselves before.
Mm-hmm.
So you can look at it like that. It's an enhancement of tooling, but it's also a bit of a, shall we say, standards and practice changes that have kind of been implemented over the last, I'd say, couple of years.
Yeah, and I think GitOps for me really means also having everything configured in one central place, and that's where everything kicks off at the end, right? And I think
Absolutely.
and that drives us directly to talk about what prerequisites would be to implement GitOps practices in an organization. What's your experience with that?
Now, I will preface if you are going down the GitOps route, you don't need to be on Kubernetes. So I'm a serverless community builder myself, but I work a bit on Kube as well, just in the nature of the consulting businesses, right? You can implement GitOps in a serverless world. You can implement it in a Kubernetes world. But the key thing that's present and common amongst all of them is codified everything. Your application, obviously codified. Your infrastructure, codified. Because only then can you apply the practices that take advantage of those capabilities.
Yeah, that is the same thing that I have in mind when talking about GitOps. What I'm not yet clear, and that's what I'm trying to learn, is how do you integrate CI practices in your GitOps workflow? Because that's something that I don't have an answer really yet. Maybe you can share some light on that later.
Well, absolutely. And to kind of like give a sneak peek on that, I think just because you're using one doesn't mean the other disappears. Just as a precursor.
Cool. Then let's try to level set a little bit. Let's talk about what GitOps essentially is. How do we see that? And let's dive into the million slides that you have prepared for today.
Okay, trust me, it's not going to be million with boring. I like a bit of action to my slides. So, do you mind if I present and we kick it off?
Let's go.
Cool. Alrighty, let's have a look. And let me see when you can. Let me tell you when you can see that. Great. So look, it's GitOps with ArgoCD and CDK the focus. EKS Blueprint's been the focus there. Why are we taking the approach with CDK? Whether you're writing TypeScript or JavaScript, Python, Java, C Sharp, Go, uh, what do they all have in common? You can write TypeScript. And, well, that is the main focus of CDK. Oh, we're having a bit of slowdown here. Bear with me. And what is CDK effectively? It's a wrapper for CloudFormation. And the wonderful thing there is we can ignore CloudFormation's perspective, as in the 3,000 lines of JSON and YAML plus that we have to create. We focus on a few lines of code. And EKS blueprints, it's written in CDK. It means that we can actually deploy and get Kubernetes bootstrapped and ready in a relatively quick manner. What if I don't like CDK, you might ask?
Yeah.
Which I think you're more of a Terraform person yourself. That's okay. You can do it in Terraform. Oh, you're not. You're more of a CDK person.
I'm not. I'm more the CDK person, but my day job uses Terraform. So I'm on. Yeah. But anyway, I think that's the important piece, right? Blueprints is not built by us. We can just use them. So let's go.
Exactly. And don't worry, we'll convince them to use CDK TF instead.
Sounds like a
But
plan.
anyway, what is GitOps? Because we've talked about CDK, right? Where does Argo come in? Well, it's our Lord and Savior Git that kind of gets involved here. At the end of the day, what we really focus on with GitOps is that it's still people that apply CI/CD, but want to try something a little bit new, you know? Instead of just going for vanilla, we're trying French vanilla. There's an enhancement of what was previously had there, and its flavor is still very similar. In a nutshell, this is what kind of looks like. You'll typically have your application infrastructure, and what's missing there is your config, all linked up to a Git hook, which connects to some sort of GitOps tooling that in the Kubernetes world will then interact with the API server on your behalf. Quite a lot of that in the past, you'd have to have a kubectl apply in your CI/CD pipeline using Helm, and guess what? None of those things disappear. When you are going through that GitOps approach, you more or less still continue to use those tools, such as Manifest and Helm charts, but you're not writing the executable CLI, and you get a much prettier interface. What does it look like? From a code perspective, this is just the only sneak peek I'll show you before we actually dive into my IDE. And as long as the demo gods are good to me, we can see what a deployment might resemble. So I'm just going to stop sharing from here.
Cool.
Right.
So before we go into the code details, right? We have that workflow that you just presented from a GitOps model. It starts on the Git side. That means a developer commits something to Git, and I hope that we're going to see that later. And then it applies some resource changes. And as you already mentioned at the beginning, it doesn't need to be Kubernetes changes. It could also be cloud infrastructure changes that are applied with the same model. I think that's the important pieces as well.
Correct. And I feel that there's been a lot of marketing around GitOps being very heavily Kubernetes focused, only because the Kubernetes landscape is so large and so, shall we say, an abstraction layer on top of what you've already built inside of AWS, that it's a great marketing tool. But don't forget, at the end of the day, code is code, no matter how you ship it.
That's true. Yeah, that's true. And that means you can use it for serverless stuff as well, or for other parts of the application. And one question on this, because Git has multiple branches. So how do you hook up the different branches with the GitOps model? Would this only fire off from main branch, or would this fire from different branches? What's your strategy on that?
So you still apply the methodologies you've learned through continuous delivery and continuous deployment, right? You can go through the gated approach where you have continuous delivery, where at the, for example, production stage, you can have a manual gate that says, I will proceed and deploy to prod when someone has approved it. So this is where tools like Argo come in, where they'll give you a visual representation of what you're about to do. And that's great, because at that point is when you are trying to push for GitOps, you don't eliminate the great things that make CI/CD fantastic, which is stopping production from blowing up. You can take the branch approach as well. So because we're dealing with Git hooks, it's just a matter of the strategy that works best for you. You may create, in Kubernetes, for example, when you create a branch focusing on a ArgoCD application, you may actually create a virtual kubelet, or effectively a virtual cluster that will then go ahead, point to existing cluster, create a temporary one, deploy it, and then run, and then delete its course afterwards. And if you really need to go for a more traditional model, Argo has something called Argo workflows. Now, it is more of a DAG, so for data augmentation and such. However, it has been used in the past, and we've previously used it in the past as a supplement to GitOps, and without removing the tooling that makes it fantastic or what it is today.
Okay, cool. Now, let's jump into your IDE.
Awesome. All right, let's hope the demo gods are good to me today.
They will be. I'm pretty sure.
So, for starters, we're in CDK land. So, for those watching through YouTube or happen to be listening in audio, we will be looking at things in TypeScript. Good thing is it's not JavaScript, so I'm sure only half of the usual people will be upset. But that's okay. So from a basic perspective, before we kind of continue, when we look to the left, the breakdown of CDK is you've got your most important components being your bin and your lib. Your lib is where your stacks will exist, and in AWS land, you can treat that like your CloudFormation stacks, and they are a very close representation of that, typically almost one-to-one. And then you have your bin, that's where your CDK app exists. Now, from a CDK perspective, what that actually looks like is that the app will be the transformative force that brings together all the stacks, and as well as the abstractions and the functions you've created to generate out your CloudFormation templates, and is also the deployment mechanism in which things will process. For example, lines 7 to 9 are declaring I'm using my default account, my default region, as well as an environment file that I'm passing through to my stack, all coming from my local CLI. Now, a lot of this will actually seem familiar because this is all just a CDK init command that we've run to actually generate the initial components. Onto the EKS side. Now, this isn't much code. I'll be blunt and say that. But this will be an initial bootstrap that generates out a EKS cluster. And what we're effectively declaring here is on line 15. We're using the builder process that comes with EKS blueprints to basically generate a auto version, which in AWS land means the latest, at least for this case. Sorry, go on.
I was just gonna say line number 4 includes an EKS blueprint, L2 construct, I believe, or is it? It's correct. An L3 construct, I guess, right? And the L3 construct contains the definition on the infrastructure requirements that we actually need, and this makes it pretty easy to kind of get started with CDK on this road. There's one thing that we usually don't talk about when presenting CDK code, which is that this is usually the simplest way of deploying stuff in a non-organizational standard, right? Because this would never work in my org, right?
No,
maybe let's talk a little bit about the defaults that are assumed here and these kind of things, because it always looks that easy, and then if you get to it, you lose days.
Well, absolutely. I mean, the reality is we want to see, what's under the bonnet, right? And in our case, we can actually step into any of the L2 or L3 constructs. And for those listening, L2 are typically constructs that combine multiple AWS services and resources that either AWS have created, or when you go to a L3 construct, you yourself have created. In the same way you would modularize Terraform, for those who are not very familiar with CDK. But I digress. What we'll actually do, we're actually going to step into this EKS blueprint class called EKS blueprint.
And who maintains this?
So this is actually maintained by AWS, and it's consistently maintained by AWS. To give you a bit of perspective, we work heavily with AWS and AWS ProServe on Kubernetes engagements, and this is what they still lead with and provide a ton of support to. Mind you, though, they also do provide commentary and issue generation through GitHub. So if you come across an issue, as they have come across in the past, there are solutions available.
Cool.
So let's continue. And once you actually step into it, you'll see that if we just go to the very top, they have Kubernetes itself is using, or the EKS blueprints are using raw CDK, because we obviously need to have an interaction component. They're using their own dedicated folder components called an SPI, and that effectively, when we were to quickly search that up, and gotta love the search function, that's used across the board when we're actually generating cluster add-ons, and if we scroll down further, resource providers. And then finally, they've got their own list of utilities they're created through constraints. Now, the first default you'll notice immediately at the very top is just a version when you don't declare anything. And they're going for version 1.27. However, as we all know, AWS has, I think now, leading the charge by having version 1.29 already ready for EKS. Now, I'm running in a componentized version that I know will work. I didn't want to risk of pulling the latest, going through a demo, and then everything's changed. There's things may happen.
No faith in your demo god, Bojan.
Look, I've made my sacrifices to the demo god, but you never know how they can respond. But I digress.
Yeah.
The wonderful component is that if you've ever worked with a TypeScript application and you've generally pulled a library from somewhere, or if you've pulled a CDK library from somewhere, you will get that same sort of approach here. This is just a framework enhancing CDK, not so much being a distraction away from CDK.
Yeah, so there's a lot of things under the hood here, I believe. And this is great because others have made the work for us. How do you see the challenge of this being too easy to use, which then hides some of the stuff from people that want to troubleshoot things?
Well, that's just it. It's at the end of the day, it's still CDK. You have escapes and you have the ability to step into your L3 constructs that and L2 constructs that have been generated. The only thing is that this is where you got to be buyer beware, is that in the long term, this may be a fantastic tool for pocking, building out sandpits and the initial components. Whether it's ready for production or not, you need to consider the caveats that kind of come with an all-encompassing tool. For example, you may actually need more logging types than the declaratives that have been set by the control plane types here. You may actually need to expand further on what the definition of teams are. You may not even use it. So I would say that this is a tool right now in its current phase that is a accelerant into EKS with minimal resistance.
Yeah. And I think it still requires you to understand what's happening under the hood. And that's something that we forget sometimes, right? We just throw this on engineers and tell them just use it. It's easy, and it all works on the happy path. But the moment that you deploy this EKS blueprints into a VPC that doesn't have public subnets because you're not allowed to bring up a NAT gateway or an API, an internet gateway, then this one will not work, right? And I think that's a lot of things that we don't really talk about when we present cool things like this.
Yeah, we need to kind of be honest about what we're building, right? And I think the reality is that showing the initial path of least resistance will help bring down barriers that will eventually lead you to your final solution. That's the way I see it.
Yeah, I agree.
Yeah.
Cool. So now this is not GitOps yet. This is just CDK blueprints. So we are 17 minutes in. We are way apart from what GitOps is supposed to be. So let's move on.
Absolutely. So to quickly just throw this out there, where the GitOps component kind of comes in here is when we actually have an involvement from the ArgoCD side. Now, why are we actually treating this?
What's Argo?
Well, thank you for asking. Argo is, I would say, one of the more popular tools for GitOps operations in Kubernetes. So whether you're on AWS and the other various clouds or even on-prem, ArgoCD is a great tool to actually bring you to, shall we say, a landscape that delivers GitOps. So it provides a UI, it provides an interface, something similar to what, the name escapes me actually, I just was talking about a moment ago, a service catalog tool that is available for Kubernetes. Generally, the name escapes me. Anyway, it provides almost a single pane of glass for all things Kube that you're about to deploy. And unfortunately, to get to that point and show it to you, and the reason why I say unfortunately, we have to look at a bit of YAML.
Oh no.
Yeah.
YAML.
So we're devolving to YAML engineering. Apologies, but you can't escape.
It looks like it. Okay, so ArgoCD is a tool that would now live on top of our Kubernetes cluster.
Correct.
And
we'll live
that
within.
Actually, live within.
Sorry,
okay. No, and I think that, we have like at least 10 seconds delay or something like that. ArgoCD is an add-on for the EKS cluster. That means it lives within your EKS cluster, and it now is going to watch Git, or what's the idea?
So that's exactly right. So off the initial cusp, the idea of why we're actually using CDK here is you would point the add-on to a bootstrappable repo of your own that on the initial startup phase, Argo will actually set up and configure the Git hook tool, webhook, either at the Git, and I'm going to use GitHub as my most recent example because that's the one I worked on recently, either at the GitHub organization level or at the Git repo level, that where you can actually set the standards where, for example, if a commit has been changed to main/master or another branch, an ArgoCD application will be processed.
Cool. So this CDK would be executed somehow using GitHub Actions, or locally it would bootstrap the EKS cluster on your account. It would then add the ArgoCD add-on, and it would configure webhooks and connection to the Git repository where now the definitions that you want to be deploying would be available, right?
Correct.
Cool. Then want to have a look on that piece as well, I guess.
Sure.
I don't think that we need to waste 14 minutes to see EKS bootstrapping, or 17 minutes. I think is the best I was able to do.
869 seconds. That's the best I got. I mean, it's unfortunately still EKS. It's slow.
Yeah. Dear EKS team, we would like to have EKS clusters that come up faster, because that would make us happy from a developer experience perspective.
Oh, absolutely. But, we could do it faster if we roll our own, but never roll your own in the cloud. Just pick the control plane of your cloud provider.
Yeah.
So
cool.
The process is a bit too I would say too prone. And see if I can just quickly share my screen again. So the reality is, and this is unfortunate because it's in a transparent background, so my VS Code decides to show it this way. When you go down the GitOps route, where, for example, you have a cluster configuration change, for example, in Helm or Customize or any of your Kube manifests, that hook that actually gets sent through will produce something called an Argo sync. What Argo does in that case, and what GitOps will do, and I'll stop using the word Argo, but let's focus on GitOps, because Flux, as well as Argo, actually effectively work in almost an identical method. And if you look back far enough, Argo actually has some of its heritages tied to Flux. So probably some bit of... closet digging others can look through online to find that, but feel free to have a look. Nonetheless, and what will actually happen is Argo will actually do a comparison between the incoming manifests and Helm files, which are obviously just templating for manifests in the background, and do a diff and then do a sync if set up in that manner. And the benefit here is the fact that you then really worry about just the code being correct, because the diff will actually determine if it's been malformed. The reality is, are we moving away from CI/CD practices? Absolutely not, because your image building may still be tied to GitHub, for example. So GitHub Actions image builder, go right ahead. Do a Docker build, Docker push to ECR or into whatever repository of your choice, or if you're unfortunate enough to be using Artifactory, as most enterprises are, and that component still has to exist outside of your GitOps operations.
Okay, that's an important point, because it actually means that all of your CI practices need to happen before the actual GitOps process kind of starts, because GitOps is more an approach for deployment and maybe also continuous deployment and reconciliation. I think that's an important differentiation, right? So your CI/CD practices will not go away when you implement GitOps. You still need to have, especially in enterprises, but also when you're building your own pieces, a continuous integration part where you actually run unit tests, integration tests, and something like that. This cannot be replaced by the modern tooling for deployment, right?
Absolutely. And then you obviously need to consider, it's like, how does the watcher watch the watchers? Because GitOps operations are basically sitting there, and this is why we have this folder structure, which I'll explain shortly. GitOps operations have a fashion of, I'm waiting for something to happen, so I happen to do my task, right? Mm-hmm. So it's in a heartbeat process, or it's in a GitOps, a Git webhook process, in which will actually, it will pull, a API will be sent effectively from GitHub to the Argo server or to the GitOps server to then execute what it needs. So in Argo land, we have a concept called app of apps. And that's where you effectively have a combination of a single application that's watching the rest of the applications. And what that does in ArgoCD, it basically prepares the rest of the hooks that you'll have across your various repos. So, for example, Hello World, our Nginx application, our Kubernetes dashboard, our pod info all have one thing in common. They all happen to be using an application.yaml file to declaratively point to a repo, point to a revision, a path. So if you happen to come from a world whether you're polyrepo, monorepo, GitOps, you can still take advantage of whatever structure works for you. whether you be an individual that has multiple repos, you can just use that repo URL and default to your, slash path. Or if
So
you're
this,
a
yeah. So this YAML gives us enough freedom to decide on where we want to point our application to and where we want to ArgoCD pull out stuff. But it forces us to write YAML, right?
Yes, but that doesn't mean that's inherently a bad thing. Standards and practices can be good, even though you're forced to use YAML at the end of the day. You can't escape with Kubernetes GitHub operations at some point or another, still utilizing YAML in one fashion or another. There are abstractions to that, but when you are working with the direct applications, you want to deal with what you can manage. And in a way, you want to abstract away to a layer that in which you know what's going to happen, instead of having the unexpected happening in production where thousands of dollars per hour per minute can be the consequence.
Yep, makes sense. Okay, cool. What about ArgoCD workflows? Is this a thing for you already today?
It's different. ArgoCD workflows, unfortunately, is not something that I have up to show at the moment, but it is in the same fashion as, for example, GitHub Actions are. It can be a YAML-based, and this is why I'm saying it again, a YAML-based CI/CD tool within Argo. So you can actually use something called Argo events, and this is where we're looking at gitops on the wider spectrum, how it's done at the enterprise, and I'd say on the production side, not just how the blogs say they're actually done. You have an event that's picked up that gets translated and executes all that. Go on. I think that's a 10-second delay.
Yeah, I'm sorry. Then let's do another session on that, on how do we use ArgoCD workflows to actually replace our CI processes that sit external, because we just talked about that, right? We need to have CI processes before we actually go into Argo. Now, with ArgoCD workflows, we might have the chance to even get that executed on the GitOps way if we do things right. So I would love to look at that. And if you have some experience, let's look at that together, maybe as a follow-up, because that would be very interesting to me.
Absolutely. And I remember the app, by the way. It's Backstage. Backstage, Argo workflows, and ArgoCD are all tied strongly together. That's what I wanted to say earlier.
And that brings us to Canoe, which kind of completely comes together as a reference implementation. Using ArgoCD, using Crossplane, using Backstage, using all of that fancy stuff, kind of, that should enable you to do GitOps right out of the box. Okay, so we looked at CDK provisioning the infrastructure. We looked at ArgoCD and the folder structure in your Git repository for provisioning ArgoCD applications or applications through ArgoCD. How does Crossplane come into the mix? Why is that in the mix? Why is it important? What problem does it solve?
Crossplane, from my perspective, I didn't really use much of it, and I'll be very honest with you. Main reason being because my initiatives with Crossplane was that it was basically get it up and running, and we had a separate group of engineers. I'm not one to say that I used quite a lot of it myself, but from my understanding is basically it's a bit of a control plane mechanism for orchestrating some of the applications and infrastructure. That is, I'd say, the limitation of my knowledge of that, unfortunately. I won't lie to you.
Okay, so my understanding of Crossplane is, in addition to that, that ArgoCD makes the connection to GitHub, and Crossplane then gives you the possibility to also provision infrastructure using custom resources or composite definitions of resources. This also enables you to bring up not only Kubernetes resources, but also AWS resources that you can also solve in different ways in Kubernetes, but you kind of get that out of the box with Crossplane. Also, in addition to that, Crossplane is supported by multiple major cloud providers, and that gives you the freedom and possibility to abstract multi-cloud resources using Crossplane. I haven't seen that in production.
That's a scary word.
I know,
multi-cloud.
But it's important to start talking about that from a perspective, because a lot of enterprises are looking into that road, and that's where Crossplane aims to solve some of the challenges that we as developers have with that.
No, it does, and I think that translation layer between the multiple clouds really does kind of help. Effectively, you're not writing in a particular language, and this is, again, my limited knowledge of Crossplane, but some I can at least comment on. it's close ubiquity to what you'd have in the same sort of fashion that you would have with something that Terraform tries to sell as, where it's the multi-cloud tool of the future, except it's hidden behind, I have, a cluster I need to create, or I need a node to need to create. Well, I just kind of focus on the minimal design that I have to implement. I don't have to focus on a very Azure or AWS centric approach. I just focus on not even vendor, just compute and storage approach. AWS has something similar. They have something called the ACK controller from AWS. It's the AWS controller for Kubernetes. You can create API gateways that link into your infrastructure, your ACM. You can create ALBs, even though you should be really using the load balancer controller for that. Except obviously it's AWS centric.
Yep, makes sense. Okay, then now let's look at ArgoCD actually deploying something for us. Can we get that working? What do you think?
I'm waiting on the deployment side, so bear with me. Really hope the demo gods will be good to me. Just for everybody's sake, in the background, I've been deploying this as in I pressed one button and have been hoping everything goes well. So let's see how we go.
Let's see if you ate your dinner earlier today and
or is my dinner going to be eating me? Oh no, it's not deployed. Still waiting, unfortunately, for AWS to come up.
That's not a problem. We can cut these pieces out if you want to. We can also...
I think we might want to cut it out, only because it's just not coming up at this point.
That's not a problem, because I would have an ArgoCD instance deployed that you could help me to walk through if you're interested to do that. So
yeah, absolutely.
we see ArgoCD, which is a UI, and now as you can see, this is deploying Canoe, and there's some applications on it. So maybe you can use that to tell us a little bit about how this kind of looks like and how this works.
Absolutely. So what we have in front of us is the Argo UI, and this is one of the benefits of Argo as compared to, say, for example, raw Flux. You have the ability for the Argo server to be interacted with to see what you're actually about to deploy. Now, just as a preface before we continue, everything that you see here can be grouped. So if you need to look at a specific project or a specific label, just like we have in the cloud console, lens with AWS console and Azure, you can still see what you need to see. So what we actually have is these are all individual applications that have been deployed. And what we see here is each one will actually detail the location, which is the repository they're pointing at, the revision, the destination, i.e. the namespace in which they will actually be deployed to underneath, in this case, Argo Workflows. Or in this case, specifically, the destination is referring to the cluster in which it's being targeted at. So if we were to step into, for example, the first one for ArgoCD, if we just click onto that.
I already did.
Awesome. I think it's that 10-second delay on my side. What you actually see is the namespace you'll create, the services you'll create, the pods, as well as the connecting services. The wonderful part is that you don't have to have a high-level design, although you should, for your application after you've deployed it using Argo. It exists live. So for example, we can see that about halfway down on the screen, we have something called the ArgoCD DEX server that can be used for authentication if you need to connect it to anything like Azure AD or DEX-based authentication services. It'll tell us the replica set that it's actually pointing to and the active live pod. From that point on, if you happen to be on the SRE side where, let's just say you need to support what you've built, you can step into the container, you can see the direct logs. And Argo actually works as a bit of an all-encompassing tool to kind of provide some context outside of what we have just as a deployment mechanism. So for example, if we had an error here that was failing, we'd, for example, see it as a config set that wasn't accepted, or for example, a secret hasn't been pulled through, you'll step into it and know it straight away. Beyond
That's
that,
cool. That means it also is kind of an interface into the kind of different, pods itself, right? So I don't need to use kubectl.
Yeah, it's a single pane of glass. That's the part that everybody has been trying to do since the dawn of time in our industry, right? And Argo kind of paints that. Now, this is what I like as well. It'll tell you how it's actually performing. Now, what's actually happened is that the application, we can see it has failed, and it's saying that the current package revision is unhealthy. The best part of this is that we actually know that A, the exact error that's actually occurred, B, the timing, as well as that the previous revision was successful. So there's ways in which we can actually roll back. This is where we get to the discussion of how do you do this. Now, you may actually choose to point to a previous commit and then do a sync. Now, what Argo does in that sync side is where it'll compare what we see here, the live manifest, to a previous manifest, and then basically rewrite the incoming. Sorry, not rewrite the incoming. Rewrite the existing with the incoming, and then execute that manifest itself. So, for example, we might have an error here with one of the providers that has been set, or, for example, with a spec.
I didn't look at that.
Could be many things, but we'll list the notes in a degraded state. And it'll actually tell us where it's degraded. So if we scroll down, we know that it's the provider for AWS logs that we just saw there.
Where did we see that? I missed that. But I
So
think,
scroll up a little bit.
Sorry. 10
That's
seconds
okay.
delay.
There we are. It's got a little broken heart because I think if we all get woken up
That's
at
the
2
provider
a.m.
for DynamoDB in this case.
In that case, it's Dynamo. So you can step into
There's
it and actually
up here
troubleshoot.
is the logs one. But anyway, this is Dynamo. Unhealthy package revision.
Could be the Crossplane provider. Could be many reasons why it's actually failed, but at least you have an understanding. GitOps doesn't just mean I deploy and I set things away. There is an approach you need to take with the troubleshooting component of it, because we'll all be doing that at one point or another. But that's just one Argo app. Now, take your current Kubernetes landscape, segment the pods that you've deployed, and shall we say the business logic around the applications that you have, that's your application. So if, for example, your application is made of a service with a bunch of pods that also has a sidecar for Istio, and then it has an auth-z sidecar, your application will point to where all that is. And then wrapping that up in that ubiquitous language, and this is taking words again from domain-driven design, you make well-produced GitOps and you make well-produced ArgoCD.
Cool. That makes sense. And I would also have the possibility to, if I set up Argo correctly, to create applications, most probably using ArgoCD UI, which would then automatically create the YAMLs for me on the Git side, right? In the
Correct.
example that we just looked at, that will not work because this is a POC that I've been working on and credentials have not been set up accordingly. But in theory, this should work, right? And then you would have the possibility to manage your Git as well from Argo, and which then once again will reconcile for you.
Yep.
Okay.
The idea is you move away from double handling everything. You just have that single place where almost everything is done from.
Cool. Let's try to do a little bit of a wrap up, Bojan. What do you think is the main takeaway from our conversation today?
The double handling with CI/CD in the old world is now onto a new phase. It's still relatively fresh. I think it's only been about maybe 4 or 5 years. And why I say that's fresh in our industry is because it's very quick to release something, but it takes long to adopt it. And adoption has really skyrocketed, only because people are seeing the ease of use case at the production level. I think, as you mentioned earlier, quite a lot can be released a bit half-baked, but we're at the point now where it's about fresh out of the oven. So I feel that the evolution of CI/CD has mutated and created GitOps. It's working side by side. It isn't a removal of it, it's an enhancement of it.
And I think that every team needs to choose how the team wants to solve the different challenges, right? This can be in a GitOps model, it can be in a GitOps-like model, but tools like Argo make it easier to reconcile and automate deployments on top of resources, in this case Kubernetes, but there are other tools around that can help us to do that as well. I think off record we talked about CloudFormation, Git hooks. Maybe you can talk a little bit about that.
Sure. So even AWS as a vendor has decided, hey, GitOps operational like makes sense. There is another community builder, Matt Gillard, who created a wonderful article, so feel free to Google that, where it actually shows that you can actually have a Git hook straight to your CloudFormation medical console service, where whatever CloudFormation change you make will then be reflective of what will be deployed in CloudFormation itself. So if you're working on CloudFormation or SAM, and I need to double check whether SAM is still of that same nature, or even if you have a workflow that will generate your CDK as a CloudFormation template and save it somewhere else, you can effectively take the gitops approach.
Yeah, cool. Sounds like that is something that will make it easier for developers going forward to know what the state is, right? Especially as reading infrastructure as code in Git or in your IDE is sometimes easier than seeing that in any kind of toolkit, right? And I think that's where that approach comes in and is very appealing as well, right? Because you also have the version history. You can put changes on the pull request control and verifications before you actually apply them. These kind of things is what makes the GitOps model very appealing.
Yeah.
Okay, Bojan.
From the early 70s Git, it's still the best thing we've released in IT, I think.
Yeah. Well, version control as a sense, right? Maybe Git is the current leading one, but there have been others that solved a lot of challenges in the past, right?
Sure.
The one that yeah, exactly. ZBS as well, and the one that I started with, I think that's also still around, right? It's rename files to have more numbers behind and bigger numbers behind, right? So I always renamed index.html was index.html1, index.html2, index.html4, and kind of that went up very well when we didn't have version control.
Yeah.
Bojan, where can people find you and the work that you do? What drives you from a community perspective? Tell us a little bit about that.
Well, first of all, if you're in Australia, either Sydney, Melbourne, or Brisbane, I speak at the user groups for AWS as well as the serverless meetups there. So recently I've spoken at the serverless meetup in Melbourne and Brisbane, and I'll be actually speaking at the serverless meetup in Sydney on the 7th of March, which the video might have come out before then. Otherwise, find me on stateofserverless.tech. It's where I post my blogs. It's a new site, and I've tried my hand at front-end development. So, yay for working with CSS.
Cool. Okay, and then LinkedIn or X or any other socials that you're very active on that people can find you as well?
Come find me on LinkedIn.
Cool. Then we'll put that into the show notes. And thank you so much, Bojan. This has been great. Looking forward to maybe do the ArgoCD workflows one soon, and see if we can make that work for us.
Absolutely. Thanks for having me, and